The red-tailed hawk, the apex aerial predator of North America. The bird with the scream Hollywood puts in every action movie to signal raw, untamed power. These birds are supposed to be apex predators, so why are they fleeing a bird that weighs 50 grams? If you search online, you'll find thousands of videos showing the exact same bizarre scenario. A hawk flying as fast as it can, actively fleeing the area, while a tiny gray bird chases it down and doesn't stop. This isn't one scared hawk or one unusually aggressive mockingbird. Wherever these two birds overlap across North America, the dynamic is exactly the same. The hawk runs. The mockingbird follows, sometimes for blocks. When you think about it, it looks ridiculous. You have a bird that kills rabbits and snakes getting chased out of the neighborhood by something that weighs less than a golf ball. The hawk isn't confused. It has learned something about mockingbirds that most people haven't. To understand why the hawk doesn't just turn around and end this, we have to look at what these birds actually are. A red-tailed hawk weighs around 1 kilogram. It has a wingspan approaching 1.5 meters. Its talons generate enough crushing force to snap the spine of a rabbit in a single strike. In a straight-line dive, it reaches 190 kilometers per hour. It is, by any reasonable measure, one of the most effective aerial killing machines on the continent. And here is the exact problem. Those massive wings, the thing that makes the hawk so deadly to animals on the ground, are an absolute liability in close-quarters aerial combat. A hawk operates like a semi-truck. To change direction, it has to bank its entire body, bleed off all its forward momentum, and slowly arc around. If a hawk wants to turn and grab something directly behind it, that process takes several seconds and covers a significant amount of airspace. The mockingbird weighs 50 grams. Its wings are short and stubby relative to its body. It can pivot in midair in a fraction of a second, stop, drop, and completely reverse direction before the hawk has even begun to turn. So if the hawk tries to spin and grab the bird harassing it, by the time the hawk is facing backward, the mockingbird has already gone around it and is now attacking from behind again. The hawk literally cannot turn fast enough to catch a dodging mockingbird in the air. Think about what that means for a second. The most effective aerial predator in North America, built specifically for catching fast-moving animals, cannot catch a bird that is actively trying to be caught, because the mockingbird is simply too small and too agile to be grabbed by something operating at the hawk's scale. Fine, the hawk can't catch it, but surely it can just fly faster and leave the mockingbird behind. Here's where it gets more complicated. When a single mockingbird spots a hawk entering its territory, it starts screaming, not quietly. Mockingbirds are one of the loudest birds in North America relative to their size, and their alarm call is specifically designed to carry as far as possible. What that call does is alert every mockingbird in the area. Within minutes, the hawk is no longer dealing with one 50-gram bird. It's dealing with 10, 20, sometimes more. This is called mobbing. And if you couldn't tell, it's extremely effective. The mockingbirds don't just swarm randomly, they coordinate. One dives from the left, forcing the hawk to flinch and drop a wing. The exact second the hawk is distracted, two more come in from above and hit it from behind. They box the hawk in from multiple directions simultaneously, forcing it to constantly dodge and dip, burning energy and getting nowhere. The hawk is never fighting one small bird. The entire neighborhood is jumping it. But even with a dozen mockingbirds, it still sounds more annoying than dangerous. So why is the hawk actually afraid? Being an apex predator, it turns out, is a terrible position to be in during this kind of fight. If you're a prey animal, a rabbit, a mouse, your only job is to not get eaten. If you fail, you're dead. But that's the only consequence. If you're a predator, your job is to successfully hunt and kill something every single day, or you starve. And hunting requires absolute physical perfection. A red-tailed hawk dives at 190 kilometers per hour to hit a moving target the size of a fist. For that to work, its vision needs to be flawless. Its primary flight feathers need to be perfectly aligned for aerodynamic stability. Its depth perception needs to be exact. If a mockingbird, during a mobbing attack, gets lucky and its beak scratches the hawk's eye, the hawk goes blind. It can no longer target prey accurately. It misses. It starves to death. If a mockingbird manages to snap one or two of the hawk's primary flight feathers, the hawk loses aerodynamic stability. Its dives become inaccurate. It misses prey. It starves to death. Now ask what happens if the hawk turns around, burns an enormous amount of energy dodging a mob of birds, and actually manages to kill a mockingbird. It gets a 50-gram bird, which barely contains enough calories to replace the energy the hawk just burned catching it. It's roughly the caloric equivalent of running a sprint to win a single raisin. Winning this fight yields almost no reward. Losing, taking even one single hit, can cost the hawk its ability to hunt. The math is catastrophic. The hawk calculates the risk, realizes the numbers are terrible, and tries to leave the area as quickly as possible. Running away isn't cowardly. It's the only rational decision available. But here's what makes this calculation even more lopsided than it looks. The hawk isn't just risking a single hunting trip when it stays and fights. A hawk that loses a primary flight feather doesn't just miss one dive. It hunts at reduced effectiveness for weeks until the feather molts back. A hawk that takes a beak strike near the eye doesn't just have trouble today. It may have compromised vision for the rest of the season. In a bird that depends on perfect depth perception at high speed to catch fast-moving prey, slightly impaired vision is not a minor setback. It is potentially a death sentence played out slowly over weeks of missed hunts. The mockingbird knows none of this consciously, but evolution has produced an animal whose behavior exploits exactly this vulnerability in a way that is so effective that the largest hawks in North America have behaviorally adapted to simply avoid mockingbird territories. But here's the thing about mockingbirds. They take it further than just defending territory in the moment. You might assume the mockingbird is running on pure instinct. Big bird, brain flashes danger, attack. But a study published in the Proceedings of the National Academy of Sciences in 2009, conducted by researchers at the University of Florida, revealed something that changes how you understand these animals entirely. Mockingbirds recognize individual humans. Researchers had volunteers approach mockingbird nests daily for 4 days, touching the rim of the nest each time. The birds never touched the eggs. They wore different clothing on different days. They approached from different directions. After just 2 days, the mockingbirds began reacting to that specific person before they even got close, flying off the nest, sounding alarms, dive bombing, while ignoring hundreds of other people walking by the same nest on the same day. The birds weren't reacting to humans generally. They were reacting to that human specifically. Subsequent research confirmed this even more precisely. Mockingbirds distinguished between multiple familiar humans who posed different levels of threat, calibrating their response exactly to the level of risk each individual represented. Not familiar versus unfamiliar, not human versus non-human. Specific individual graded to specific threat level. The researchers hadn't expected to find this in a common backyard songbird, a level of individual recognition they'd previously associated only with corvids and parrots. They do exactly the same thing to hawks. If a red-tailed hawk flies over a mockingbird's territory and gets mobbed, that specific hawk, its size, its markings, its flight pattern, gets remembered. If that exact hawk ever crosses into the territory again, even months later, even at high altitude just passing through, the mockingbirds target it immediately. The hawk thought it left the problem behind. The problem has a very specific memory of the hawk. But mockingbirds don't stop at remembering their own enemies. They teach. Studies of mockingbird behavior have documented that when a bird that recognizes a threat begins mobbing, other mockingbirds in the area join in based on the alarm call, not because they've personally assessed the threat, but because the calling bird's response tells them this specific thing is dangerous. The threat assessment is communicated, shared, acted on collectively by birds that have never personally interacted with the hawk being mobbed. This means a hawk can fly into a territory and be attacked by a bird that has never seen it before. Because another mockingbird, one that has seen it, is in the area and has already communicated the threat. The hawk hasn't just made one enemy. It has become a data point in the mockingbird social network. And it gets worse. Mockingbirds in stable territories often hold the same nesting ground for multiple seasons. The threat recognition they develop, the specific hawks, the specific individuals, gets reinforced and updated over years. A hawk that made the mistake of raiding a mockingbird nest in a suburban neighborhood isn't just dealing with this year's pair. It's dealing with animals that have a years-long running assessment of exactly how dangerous it is and exactly where it goes. There are documented observations of mockingbirds recruiting other bird species into mobbing events. Cardinals, thrashers, even Florida scrub jays have been observed joining mockingbirds in chasing hawks from territories, responding to the mockingbird alarm call as a reliable signal that something genuinely dangerous is present. The mockingbird's alarm is trusted by other species as accurate threat intelligence. That trust was earned. Now here's the thing nobody mentions when they talk about mockingbird intelligence. A northern mockingbird can learn and produce over 200 distinct songs during its lifetime, incorporating sounds from other birds, insects, frogs, and even mechanical noises. Researchers have documented them mimicking car alarms, cell phone ringtones, and squeaky gates. They update their repertoire continuously throughout their lives. An animal that can learn and store 200 different acoustic patterns, update that library in real time, and deploy specific calls to recruit allies from multiple species. That is not a bird operating on simple instinct. That is an animal processing its environment at a level that researchers initially expected only from parrots and corvids. And it has decided that the hawk that flew over its territory 3 weeks ago needs to be treated as a permanent enemy. The mockingbird isn't just defending its own nest. It has effectively become the threat assessment and alarm system for an entire neighborhood of birds. And then there is the attack itself, because mockingbirds don't just chase, they aim. A hawk has 2 weapons: its beak, which faces forward, its talons, which reach forward and down. If a mockingbird attacks from the front, it risks those talons. If it attacks from below, same problem. So mockingbirds attack from above and behind, specifically targeting the space between the hawk's wings, right at the center of its back. This is not random, this is the hawk's anatomical blind spot. Because of how the hawk's neck and wings are structured, if something lands directly on its back between the shoulder blades, the hawk's beak cannot reach it. Its talons cannot reach it. The hawk cannot physically get its weapons to that position on its own body. There are photographs of this happening. A mockingbird will land directly on a hawk's back in midair and ride it, pecking at the back of its neck, its head, its eyes. While the hawk tries to accelerate and shake it off, the hawk is looking completely humiliated, flying as fast as it can with a 50-gram bird surfing on it and targeting exactly the one spot the hawk's weapons cannot defend. The hawk's only option in that situation is to fly faster and hope the mockingbird eventually gets tired or loses interest. The mockingbird, weighing 50 grams, does not get tired quickly. It is not operating under an energy deficit. It is burning almost nothing compared to the hawk, which is carrying a 1-kilogram body and panicking at full throttle. But here's what mockingbirds are actually after when they do this. It's not just harassment. A mockingbird's territory isn't just its nest. It's a defined area containing food sources, fruiting trees, insect-rich shrubs, feeding spots that the mockingbird has established and defends year-round. A hawk that hunts in that territory doesn't just threaten the nest. It reduces the prey available to the mockingbird. It changes the behavior of the small animals the mockingbird depends on. Its presence alone costs the mockingbird resources. So the goal isn't just to get the hawk to leave the immediate area of the nest. The goal is to get the hawk to never come back at all. To make this entire zip code so unpleasant to hunt in that the hawk permanently relocates its hunting ground somewhere else, which is exactly what happens. Hawks that have been mobbed in a mockingbird territory develop a measurable avoidance of that area. Not caution. Avoidance. They change their routes. Here's what makes this dynamic genuinely strange when you step back from it. The mockingbird is not physically capable of killing a red-tailed hawk. Not even close. If the hawk manages to get a talon on a mockingbird, which happens rarely when a mockingbird misjudges its dive by a fraction of a second, the fight is over instantly. The hawk's talons pierce straight through. The mockingbird doesn't make another sound. The mockingbird is fighting something that could end it in a single contact. Every dive, every pass, every moment of surfing on the hawk's back, the mockingbird is one small error away from being dead. And yet it doesn't stop. The hawks know this too. An eagle can kill a crow in a heartbeat, and the crow keeps coming. A hawk can kill a mockingbird instantly, and the mockingbird keeps coming. What the hawk has learned, what every hawk that survives long enough in mockingbird territory learns, is that the mockingbird has done the same math the hawk has, arrived at the opposite conclusion, and is completely committed to the outcome. The hawk runs because fighting back costs more than it gains. The mockingbird attacks because not fighting costs everything. Those are different calculations. And the mockingbird's version, it turns out, produces a bird that the apex aerial predator of North America has learned to simply avoid. When most people think about power in nature, they think about size. The biggest animal wins. The strongest predator dominates. The mockingbird weighs 50 grams. The hawk it's chasing weighs 1,000. The hawk has talons that crush bone. The mockingbird has a beak designed for eating insects and berries. And the hawk runs, not because mockingbirds are more powerful, not because they've evolved some weapon that levels the playing field, but because they have made themselves so expensive to fight, in energy, in injury risk, in the sheer relentless persistence of the attack, that a bird capable of killing a rabbit chooses instead to leave the neighborhood and find somewhere easier. You don't have to be the biggest or the deadliest to win. You just have to make yourself a problem that isn't worth solving. The mockingbird figured that out a long time ago. The hawks in its territory have all learned it since. The next video on this channel covers an animal that uses an almost identical strategy, making itself so expensive to engage that every predator in its range has independently arrived at the same conclusion. That video is next.